So, good morning. This is Daniele Miorandi speaking, Executive Vice President for R&D at UHopper. And today I will be talking about the usage of Bluetooth Low Energy for indoor location. This is the third sub-module of the iLocate module on indoor localization technologies. This sub-module has two main objectives. The first one is to provide an overview of how Bluetooth Low Energy can be used for indoor localization purposes. The second one is to provide details on the functioning of two Bluetooth Low Energy enabled localization systems, namely iBeacons and Coupa. The outline of the course is composed of three parts. First, I will present you the principle of functioning of Bluetooth Low Energy. Then we will dive a little bit deep into some technical features of the underpinning technology, and then we will see how Bluetooth Low Energy can be used in practice by focusing on two specific technologies, namely iBeacons and Coupa. There are some prerequisites for this course. One which is mandatory, the introduction to indoor localization technologies, which is part of this module. And second, some basics of wireless communications. This is not mandatory, but it will make your life easier in following this course. Now, let's start with the principles of functioning. So, what is Bluetooth Low Energy? Bluetooth Low Energy is an ultra-low power open standard for short-range wireless communications. It is based on the well-known Bluetooth standards, but with some modification. First, the focus on so-called state applications. I will explain you in a minute what is a state application. And it includes a new radio, a new protocol stack, a new profile architecture. And it aims at becoming the de facto standard for Internet of Things applications. So, let me start by recap what is Bluetooth. Bluetooth is a set of specifications for common short-range wireless applications. It is powered by the Bluetooth Special Interest Group, which currently counts on more than 24,000 members, including all major vendors in the wireless communication area. And it defines core components, radios and protocols, as well as profiles, which can be thought as templates for applications. The so-called classic Bluetooth radio works in a band which is called the ISM, Industrial Scientific and Medical Band, centered around the 2.4 GHz frequency. It is an unlicensed band, meaning that everybody can transmit there. It transmits at a rate of 1 megasymbols per second, and it employs three different modulation schemes: Gaussian frequency shift keying, 4 phase shift keying, or 8 phase shift keying. It transmits in channels which are 1 megahertz wide, and it uses a technique called frequency hopping for coexistence with other technologies operating in the same band, like Wi-Fi. It transmits at up to 100 milliwatt of power, covering a range of more than 100 meters. Now, what is a state application? Well, state applications are applications in which you have sensors that expose a state. Think, for example, of a thermometer telling that the current temperature in the room is 19 degrees. These type of applications have quite peculiar requirements. In particular, they demand extremely low power because batteries should be small and run long, in the range of 1 to 5 years. In terms of bandwidth, well, bandwidth is not really a big issue for this type of application, meaning that typically it's about short messages and infrequent updates. Latency, on the other hand, can actually be an issue in some specific application domains, where you want to have guaranteed delay in the order of less than 100 milliseconds. Actually, it turns out that Bluetooth, or better, the classic Bluetooth protocol, was not adequate for state application, and that is why people introduced Bluetooth Low Energy. Here are some key features of Bluetooth Low Energy technology. First, the topology supported. Bluetooth Low Energy supports star topology. You have one device, which is called a master, which can transmit to many devices, which are called slave. In terms of range, Bluetooth Low Energy can transmit up to 150 meters in free space. It has an output power of 10 milliwatt or 10 dBm. It has a guaranteed or expected latency of the order of 3 milliseconds. The maximal current that is drained from the battery is approximately 15 milliampere, and the sleep current, what is drained when the device is in sleep mode, is approximately 1 microampere. It operates in the 2.4 GHz ISM band, like standard Bluetooth. Channel bandwidth is 1 MHz, as in standard Bluetooth. The modulation scheme employed, here you have only one, which is Gaussian frequency shift keying, transmitting at 1 megabit per second. And we have 40 channels, which are spaced by 2 MHz, out of which 37 are data channels and 3 are reserved specifically for advertisement. And you will see in a few minutes what this actually means. Now, as I said before, Bluetooth Low Energy has been designed for exposing state. It is therefore good at small, discrete data transfer, like for example data from a sensor. Data can be triggered by local events, and data can be read at any time by a client. And the interface model is very, very simple. Some basic concepts. Well, Bluetooth Low Energy is based on a client-server architecture, which is the standard paradigms in web systems. The basic notion is that everything has a state. Devices exposing their state act as servers, and clients, typically mobile devices like laptops or smartphones, can actually use the state that is exposed on servers. They can read it, for example, get the current temperature, or they can actually write it, which enables control and actuation applications, for example, increasing the set point temperature for a given room. Servers can actually tell clients when state updates occur by sending out notification that, for example, the temperature in the room has reached the set point. Now, in many cases, clients can act as gateways, allowing interconnection of the Bluetooth Low Energy world with the larger Internet world. As an example, you can have a waiting scale that sends reports to doctor, a home security website that shows that all windows are closed, an assisted living application which allows low-cost monitoring for your parents, or a sports data application but sends data via cellular phone. This concept of gateway is very important because it is the basis for developing end-to-end application leveraging Bluetooth Low Energy technology. Now, let's go a little bit more into the details of the technical features. We are actually not going to a very detailed description of the various technology components. We have a specific training module for that, and you can look it up on the iLocate website. One basic concept is that each Bluetooth Low Energy device includes a state machine, and each device can be in 5 different states. The first state is the standby state, what basically happens when your device is in a sleep low power mode. And your device in this state is not able to transmit or receive packets. Another state is the advertising one, in which actually your device can broadcast advertisements in advertising channels. If your device is in the scanning state, it basically looks for advertisers, and we will see later on that advertising and scanning state are very important for usage for indoor localization purposes. Then you can be in initiating state, in which you are initiating a connection to advertisers, And once the connection is set up, you can be in one of two roles. Master, you communicate with devices in slave roles, and you define the timing of transmission, or slave role, in which you communicate with single device in a master role. One important difference between Bluetooth Low Energy and classic Bluetooth is that no multi-hopping is allowed. So what in Bluetooth standard is known as a scatternet doesn't exist in the Bluetooth Low Energy world. Further, you don't have role switching, meaning that once you are in the connection mode in a given role, either master or slave, you cannot change that dynamically without passing through the standby mode, as in the finite state machines. This table summarizes what are the transitions that are allowed by the Bluetooth Low Energy state machines. We are not really going into details, it's quite self-explanatory, and I leave it for you to study the details. Now, what you see now on the slide is the Bluetooth Low Energy stack architecture. We have three basic layers. The controller layer, which basically deals with the radio and what is implemented directly in the hardware or firmware, the host layer, and the application layer. We're not really going for this submodule into the details of the various components of this architecture. We leave it for the other module, the detailed one. I just wanted to mention, because this is very important, the generic attribute profile module, which is known as GATT. This is very important because it defines templates for specific application level behavior, which is very important because it allows you to quickly and easily develop and deploy applications using Bluetooth Low Energy. So, how can you actually use Bluetooth Low Energy for proximity and access? The basic idea is that you can have Bluetooth Low Energy low-cost tags that last for many years on a coin cell. And you can use it for a number of different applications. An example is proximity. So, for example, you want to have two devices alarm when moved out of signal range. So, for example, a key fob alerts when mobile phone is out of range. You can use the same feature for running access control. So that, for example, a tablet locks you in when key fob is detected nearby. Or you can use it for personalizing user experience. So that, for example, the car is able to automatically recognize when you get in, and it can adjust the seats to the favorite positions. Bluetooth Low Energy can actually find a number of applications also in advertising. Why? Because actually low-cost advertising tags can provide local and relevant information, enabling a wealth of useful applications, very interesting for marketing people. First is actually indoor location. You can actually broadcast location in packets, or you can look up the device, and here by device I mean the tag ID, in an online database, which is, as we will see in a few minutes, exactly what iBeacons do. We can actually use it for running local product or service discovery, for example, advertising local service information or an URL for online exploration. And you can use it for app discovery. Advertise an ID that can be used to identify applications to connect to and interpret data from an accessory or service. For example, choose apps to interpret ale tag information in a supermarket or a physical store. Choose apps to describe the painting in a gallery, which can actually be used for running applications in museums. Or choose apps to let you control the air ventilation systems in your hotel room or other domotic applications. Now, details of functioning. Let's start with iBeacons. So, what are iBeacons? First of all, iBeacons are a trademark registered by Apple for an indoor positioning system. iBeacons, from the technical perspective, are transmitters that can notify nearby devices, typically a smartphone, of their presence, triggering an action on the device. And why we are dealing with them within this module is because they use Bluetooth Low Energy. So how do they work? Well, they basically use Bluetooth Low Energy to transmit, or better, to advertise a unique identifier, which is, in this case, the state of the device, which typically doesn't change over time. It is static, and it is sent out periodically by iBeacons using Bluetooth Low Energy technology. This message is picked up by the operating system of the smartphone and used by compatible applications, if available. What the applications do is typically that they get the identifier of the iBeacon device and they look up such an identifier, either locally or on the web, to decide which action has to be undertaken. Something to be remembered is that iBeacons do not send push notifications. What they advertise is just their identifiers. It is then up to the app that takes up these identifiers to decide which actions to trigger, like, for example, sending push notification to the end users. Another important thing to remember is that smartphones can also poll iBeacons. Namely, they can actually read the state, and this is something which can be used using the generic attribute profile that we saw before in the Bluetooth Low Energy protocol stack. There are two key, functionalities that are exposed by iBeacons technology. The first one is region monitoring. What it does is that it notifies listening applications of entry-exit in the region, where the region is identified by the range of one iBeacon or a plurality of iBeacons. This is interesting because it works also if the app is in background and the phone is locked, so that you can actually trigger notifications to the end users based on proximity with a given set of iBeacons devices. And in iOS, from the version 7.1 onwards, this works even if the app is not running in the background. The other functionality is ranging. Ranging basically is something which provides an additional level of details specifying what is the distance between the client, the smartphone that the user is bringing around with her or him, and the server, that is the iBeacon device. This does not work in the background. The range information is returned as immediate, within a few centimeters, near, within few meters, or far, 10 meters or more. Different ranging information can correspond to different actions triggered in the app. The kind of granularity that you get out of ranging, as you can imagine, is quite coarse. Why this? Well, because the ranging is based on the RSSI, Received Signal Strength Indicator. What does this mean? It means that the server, the smartphone, is measuring the power of the signal received from the server. However, as you know from the introductory part to this module, this might vary dramatically depending on the radio frequency propagation characteristics of the environment, which is something which is hard to predict a priori. Now, how iBeacons expose ranging information based on RSSIs, it's actually part of our proprietary protocols on iOS. So we don't actually know which type of algorithm is currently used. There is also an open source porting on the iDroid iBeacon library, so basically for using with Android operating system. But it turns out that actually what you can get on Android and what you can get on iOS might vary. So if you are in the same situation, the ranging information which is returned on an Android device might be different from what is returned on an iPhone. And of course, this is something that people designing applications should always keep in mind. So, in order to develop location-based services with iBeacons, we need three basic ingredients. One, we need a set of iBeacons properly deployed. Second, we need a backend running an iBeacon management system, allowing us to track and configure iBeacons remotely. And we need a mobile app, which defines the user experience and defines the actions that have to be triggered based on the information received from the iBeacons. It's important to keep in mind that the actions to be taken in response to an iBeacon advertising message can be defined either server-side or client-side. This is something which is left open for the mobile application developer to decide upon. Something important to remember, iBeacons do not track a device. A device can track its movements only under two conditions. First, a sufficient infrastructure is present in terms of number of iBeacons and coverage provided by iBeacons, and an appropriate app is installed on the user device, because with iBeacons, tracking is done only client-side. Now, last part of this module, it's actually details of functioning of another Bluetooth Low Energy based technology, which is called Kupa. What is Kupa? Kupa is actually a Finnish company founded in 2012, and it is a spin-off from Nokia Research Center. It sells a unique location technology which has been developed by the founding team since 2005. Which uses Bluetooth Low Energy as underpinning technology. The name of this technology is Intelligent Locating Technology, which is the evolution of a high accuracy indoor positioning or HYPE technology, which was sold by Kupa until a couple of years ago. The Kupa Intelligent Locating Technology is based on a number of devices. First, active tags. Small portable devices, battery-powered, that transmit Bluetooth Low Energy signals. Second, locators, which are antennas that are mounted on the ceiling of the environment to be monitored, and estimate position of tags based on received signal. Something interesting here to remark is that it doesn't use RSSI, but a different scheme based on direction of arrivals. The Kupa Intelligent Locating Technology system includes further a controller, which is a mini PC running a software, Kupa Positioning Engine, for processing of location data transmitted by the locators, and for commercial development, a software-only package for the Kupa Positioning Engine. Now, Kupa architecture at a glance. We have a number of Kupa tags which shall be attached to the assets to be tracked that transmit data to Kupa locators. Information from the Kupa locators is sent to the Kupa Positioning Engine where the processing takes place, and applications can actually retrieve positioning information from the Kupa Positioning Engine to provide application-level functionality to end users. Kupa's performance. The most peculiar feature of Kupa system is high accuracy, down to 10 centimeters, which is much more than what we can achieve with iBeacons. We actually measured in retail environments approximately 25 centimeters accuracy in operational environments. Another important feature for some specific applications, like for example sports application in which you might have fast-moving assets, is the high frequency. Coupa system can provide location updates up to 100 Hz. And the low latency is what basically we can estimate the position with a latency which is of the order of 100 milliseconds. So how can we actually use it for providing, or better, for powering smartphones applications for end users? We have 4 ways of doing it. The first and easiest one, what we will initially use in the iLocate project, is to associate a Coupa tag with a smartphone. So that basically we give to a given user a Coupa tag, we associate it with a smartphone app, so that basically the app can fetch data from the Coupa positioning engine and know in every moment the actual position of a user. We can also use it as the smartphone in a tag emulation mode. What does it mean? It means that actually we can run software in the smartphone and let it behave as if it were a Coupa tag. And the interesting thing is that with Android 5, we can do it without the need to root or jailbreak the phone. We can also use the Coupa system in iBeacon mode, basically using the locators as active transmitter and using the smartphone as a standard BLE server, so that basically the app receives the advertising messages sent out by the locators, and this triggers appropriate actions. And in the futures, once we will have a Bluetooth Low Energy 5.0 solution, we shall be able to seamlessly integrate data from Coupa positioning system into smartphone applications. Now, in this slide, you see a table that summarizes the different features of Coupa versus iBeacon technologies. Let me go quickly through them. Both are based on Bluetooth Low Energy as underpinning technology. Coupa is based for positioning, whereas iBeacons have been designed for proximity. Coupa supports network-centric and device-centric operations, meaning that the actual estimate of a position can be done on the server or on the client side, and by client here we mean the smartphone. Whereas with iBeacons, you can actually estimate the position only on the smartphone. Coupa provides high accuracy and high sampling rate, whereas iBeacons typically provide low accuracy of the order of few meters, and depending on the specific setting of the iBeacons devices, low to high sampling rates. Coupa has been designed for continuous tracking of access or for high accuracy wherever needed, whereas iBeacons have been designed for proximity to hotspots. Both are smartphone compatible. However, Coupa requires a tag to be associated or an app, and iBeacons requires an app. They are based on different methods for estimating position in indoor environments. iBeacons used the received signal strength indicator, as we have seen before, whereas Coupa using direction of arrivals. In conclusion, Bluetooth Low Energy is a key enabling technology for indoor location-based services. The choice of the specific technology, here we have seen 2 specific ones, iBeacons and Coupa, depends on use case features and requirements. And if you want to know more, you can actually follow the long version of this module on the iLocate website. Thanks for your attention, and if you have any question, do not hesitate to send me an email.